About algebraic fractions, some function work and differentiation. Let's start with part A. Express the following as a single fraction in its simplest form. We know the score with these ones. The key with these is step 1, try and factorise, step 2, try and cancel, step 3, if you're adding or subtracting fractions, put them over a common denominator, step 4, combine and simplify, etc. Now, looking at what we've got, can we factorise? The top can't be factorised, this bottom can't. This top can't and this bottom can't. Okay, so we're straight on to trying to subtract fractions. You can't subtract fractions until they have the same denominator. This denominator has a factor of 2 and x subtract 1, and so does this. So, in order for them to have the same, we have to multiply this first fraction by 2x subtract 1 on top and bottom. So let's do that straight away. So we would have 2x subtract 1 and we have 4x subtract 1. So multiplying that, subtract 3, and then now we can combine them as 2x subtract 1 and 2x subtract 1 in a bracket. So that would be our first line of working. Now we have no option now than to expand. Do not do this, whatever you do. Some students try and cancel at this point. You cannot do that. You can only cancel a factor which is a factor of everything on the top and bottom. So 2x minus 1 is not a factor of this term here. So make sure you do not do that. Okay, so let's expand. So if we expand this out, we get 8x squared, subtract 6x plus 1, and then we have subtract 3. All divided by 2, x subtract 1, 2x subtract 1. Okay, now the top, you can see this would be 8x squared, subtract 6x, subtract 2, all over 2x subtract 1, 2x subtract 1. You could factorise, try and factorise the top and bottom. A factor of 2 comes out of the top here, and we would have 4x squared subtract 3x subtract 1, all divided by 2, x subtract 1, 2x subtract 1. At this point you would be able to cancel the factors of 2 from top and bottom. And just to continue going, now you should continue working down the page. I'm going to just work by the side here. You should continue going down the page. Let's try and factorise this expression here if we can, see if that will help us at all. Does that factorise? So that would factorise as 4x and x. With a bit of thought, you should be able to subtract 1 plus 1. The top factorises as follows, and on the bottom we have x subtract 1, 2x subtract 1. And oh look, what a surprise, the x minus 1 cancels, and you have yourself 4x plus 1 over 2x subtract 1, and there is the single fraction you are after. Okay, part B. Given that the following, given that f of x is defined to be this, for x bigger than 1, show that f of x can also be written as this. Now, surely you will realise from part A that all of this you can write now as 4x plus 1 over 2x subtract 1. So f of x, this part of it, could be written as 4x plus 1 over 2x subtract 1. And don't forget we've got the subtract 2. So subtract 2. That's our first line. Now, in order to subtract these, we've got to make them over the same denominator. So we times the 2 by a 2x subtract 1 on top and a 2x subtract 1 on bottom. And now we can work this out. So keep this for here, 4x plus 1, subtract 2x subtract 1, all divided by 2x subtract 1. We can expand out the top now. It would be 4x plus 1. This times this would be minus 4x, or subtract 4x, and this times this would be plus 1, all over, sorry, plus 2, my fault, sorry, plus 2 here. Negative 2 times 1 is 2, all over 2x subtract 1. And as required, look what happens, 4x subtract 4x cancels, 1 add 2 is 3, so we get ourselves the 3 over 2x subtract 1 we're looking for. Easy 2 marks. Part C. Hence differentiate f of x and find f dashed 2. So let's write our f of x. Our f of x we have just found is equal to 3 over 2x subtract 1. So 3 over 2x subtract 1. And we want to work out f dashed x. Well, just before we do that, let's write this in index form. That's 3, 2x subtract 1 to the power of minus 1. Let's get all the easy marks off the examiner. Let's write f dashed x. That's the derivative here, not the inverse function. So, to differentiate this, keep the 3 where it is. Bring down the power of minus 1. Differentiate the bracket and multiply by that, and the differential of the bracket is 2. Then keep the bracket 2x subtract 1 and reduce the power by 1. So when you do that, you would get yourself negative 6 2x subtract 1 to the minus 2, which, going back to writing in normal form, that would be negative 6 over 2x subtract 1 squared, and that is f dashed x. So therefore f dashed of 2 is the answer you get when you substitute 2 in, so that's negative 6 over 2 times 2 subtract 1 squared. 2 times 2 is 4, 4 subtract 1 is 3, 3 squared is 9, so that's equal to negative 6 over 9, which simplifies to negative 2/3, and that's it, you're done there.